Drugs like heroin or LSD and crack fall under these categories. Drugs have a high abuse potential as well, but they are used in medicine. So morphine would fall under this category in oxycodone. So we also consider to be less dangerous and have a less potential than Schedule II drugs, and they're commonly used in medicine. So Vicodin would be one of these drugs. So prescription morphine is given. Typically, there's no refills that are permitted because it's a Schedule II drug. But hydrocodone, on the other hand, is a Schedule III drug, and refills are permitted when prescribed. So there is this perception that morphine is more dangerous, more addictive than hydrocodone. So based on what we know about these two drugs, we're interested in comparing the rewarding and addictive properties of hydrocodone to that of morphine, since they're scheduled differently. So some of the aims of our studies was, first of all, does acetaminophen enhance the rewarding effects of hydrocodone in drugs such as Vicodin? And we wanted to compare how similar the rewarding effects of hydrocodone were to that of morphine, since they're, again, like I said, scheduled differently. So how is reward? Reward is measured typically using a paradigm known as condition-based preference. Is an animal is injected with a drug and placed on one side of the chamber for 30 minutes. During the time, they're able to escape their environment with the rewarding effect of the drug given. The next day, they're given saline and placed on the opposite side where they're not going to experience any reward. And this is repeated for 4 days. So on a test day, the animal is placed in a chamber in a drug-free state and allowed to roam free back and forth between the chambers and both chambers, and the time spent on either side is reported. So the CTP is the amount of time the animal spends on the drug care chamber between animals that are treated with drug and animals that are treated with vehicle. So this is some of our CTP data with acetaminophen and hydrocodone. So here you see the time spent in either the drug care chamber or the saline storage chamber. This is our vehicle, and first we know that acetaminophen and hydrocodone separately, animals treated with these drugs did not induce any rewarding effect or CTP. However, when they're combined, this is a non-rewarding dose of hydrocodone. However, when they're combined, you do see reward. So acetaminophen is enhancing rewarding effects of hydrocodone at a particular dose. So what we wanted to do is take a known rewarding dose of hydrocodone, combine it with acetaminophen, and see if we get those effects, if we can get an enhancement in reward. However, compared to the two, we did not. So the next thing that we did was look at the locomotor activity of drug-treated animals. And basically what we found was that animals treated with either acetaminophen, hydrocodone, or the combination did not have locomotor activity, and this is those that enhanced reward. So the effects of acetaminophen were that on hydrocodone were unique to that to reward, and it did not enhance hydrocodone induced locomotor activity. This locomotor activity is expected with a higher dose of hydrocodone. So far we've shown that acetaminophen enhanced rewarding effects of hydrocodone in a narrow dose range. So the thing we wanted to do was look at the rewarding effects of hydrocodone in comparison to morphine adaptation. So we ran another CTP with hydrocodone and morphine, 2 different doses of drugs. And as you can see, hydrocodone at 1 milligram per kilogram of both morphine at this dosage, neither are going to do CTP or reward. However, at 5 milligrams per kilogram, both drugs induce CTP in a very similar manner, which suggests that these 2 drugs, hydrocodone and morphine, do have similar rewarding properties. So overall, what we've shown today is that acetylcholine enhanced the rewarding effect of hydrocodone. However, it did not do it in a dose-dependent manner. It was a very specific dose, which leads us to believe that it has very limited physiological relevance. Acetaminophen did not enhance locomotor-induced hydrocodone locomotor-induced activity. These effects that we saw with this drug were unique to the report. And finally, hydrocodone produced similar rewarding properties to that of morphine. So the take-home message here today is, first of all, abuse of prescription opiate analgesics is on the rise. Vicodin is the most prescribed and abused analgesic. This may be due to overprescribing of the medication, and the rewarding effects of hydrocodone containing formulations are indeed due to hydrocodone rather than other combinations such as acetaminophen. Also, these have similar rewarding effects as morphine. However, hydrocodone is classified as a Schedule III drug, while morphine is considered more dangerous and is classified as a Schedule II. So overall, it's important for the medical community to consider hydrocodone to have similar rewarding effects and properties and abuse potential as morphine. And I would like to thank the Gutierrez laboratory for all their hard work on experiments, the National Institute of Drug Abuse for funding, and Dr. Friedman and Charles for their medicine and science for having me today.
Very nice talk, beautiful data. I was just wondering, like animals versus humans have differences in pharmacokinetics to the metabolism effects of drugs, and animals, rodents in general, are much quicker with drugs. I wonder if in humans that may have slower metabolism of these drugs, whether the same type of reinforcing properties would be observed. Have you thought about that?
Yeah, and what we were showing with the locomotor activity study is acetaminophen was indeed affecting the metabolism of hydrocodone. We would have seen an enhancement in the locomotor activity within the show. And a lot of these studies are in line with to human research as well. So. Did that answer?
Yeah. How do you think they put it in?
I think they do it because they give just for hydrocodone or just for analgesic, analgesic, it's just potent and the nicotine side effects that it use. And another analgesic that is not as strong and is not going to be as harmful.
More questions? Yeah.
A question. Thanks. I really enjoyed your talk. I'm wondering if you have any idea whether acetaminophen also enhances the effect of morphine, and any idea or any insights what mechanisms might be.
You know, different things with morphine. I don't think there are very morphine not answered with acetaminophen. I don't believe that I know of. And so I really didn't answer that question, but that is commonly combined with hydrocodone or oxycodone, which are very similar, or not like acetaminophen, but I'm not sure about one necessarily.
Thank you.